measurement systems analysis, analyze gauge R&R crossed. I click next, and we'll select measurement, select part, and operator, and then I click OK. And now you're getting a more extensive, it has the ANOVA, analysis of variance, showing in this case a part by operator interaction, and then you get your confidence intervals. Okay, so again, I'm not going to cover all the details of the analysis, but the bottom line is it's very easy now, especially if you're teaching this material. You start off with a simple template, fill it in, and then you can kind of then take people to the next level and just click on the stack column button, and it will then take that template data and put it in the appropriate format for a full analysis. We also did the same thing with the attribute gauge R&R. Again, if you're attribute MSA study. So in the attribute MSA study, a few things. One is we added conditional formatting, so as you enter the values, if there's a difference between the true standard and the entered result, it is immediately apparent because it's formatted in red. So that kind of makes it a little bit easier to spot where the errors are. Okay, so that's so you have that. But then we also added the stack column button, and you just click that button, and now it's ready for full analysis under Measurement Systems Analysis, Attribute MSA, and then you click Next. And so part, appraiser, assessed result, and true standard. Click OK. And a few differences, by the way, between the output report. You get the more powerful Fleiss kappa value. In the worksheet, in the original worksheet under Attribute MSA, you get Cohen's kappa. And Cohen's kappa is okay, but it's not as powerful as Fleiss kappa. And the problem with that is Cohen's kappa can be worked out in a worksheet, but for Fleiss kappa, you need to do more extensive calculations, and so that's why we have. So that's given to you, and you just have more. You have your the MSA data given to you. So it's just a more complete analysis. And now it's really easy to go from the template to the full analysis. So whether attribute or continuous MSA, once you have your template filled out. Now, you don't have to use the template. You can go straight to to the stack column format and analyze that way as well. And okay, so that's attribute MSA. Now I'm going to switch gears, and what we're going to do now is look at the control charts and the add data to all control charts. I'm going to the data I'm going to use is the customer data, which is the data that we have throughout our workbook. So I'll switch over to the customer data, and okay. So what I'm going to do is I'm going to create individuals charts. You can actually mix and match if you have, for example, an individuals chart and an X-bar chart. The add data will work, but you just have to be consistent. If you're adding, if you have an X-bar chart and you have a subgroup size of 5, then you need to add 5 data points. If you're having an individuals chart, then whatever you add to your chart, that new information then will be updated to the control chart. I'm going to create a control chart of overall satisfaction actually, no, average number of orders per month, average days order to delivery time, and overall satisfaction. So I'll just quickly create those three charts, just one at a time. So we said average number of orders per month. All right, that's our first chart. And then we're going to do, actually I could do recall dialog. And then we're going to do average days order to delivery time. And I'll recall SigmaXL dialog, and then we'll do overall satisfaction. Okay, so we have our charts now, and so we have three different control charts going here. Previously, in 6.0, SigmaXL, if you wanted to add data to the chart, you basically have to, you essentially have to go through and click on each chart and then click on the Add Data button. So you have to do that 3 times. So what we have now is add data to this control chart, which is essentially equivalent to the original tool. And then we have this add data to all control charts. So let's say, for example, I come down and I'm going to, okay, so column D is average number of orders. So I'm gonna put large numbers in because I just want to make it really obvious, you know, the difference here. And then average days, I'll put in, say, 100. And then for the customer stat score, well, 5 is my limit, but just to demonstrate so that it's really obvious on the chart, I'll put in 6, because that was a 1 to 5 scale. But I just want to demonstrate the Add Data button. So I can go back now to any chart, and if I click Add Data to all control charts, without changing the control limits, okay, very, very important here. Unlike some of our competitor software, where when you do this add data, they recalculate the control limits. We keep the control limits fixed and simply add the data to the existing chart. And this tells you that all the charts are updated. And so here we see our first data point that has been added. Again, we see the add data at work here. By the way, the y-axis is rescaled. So the control limits do not change, but the y-axis does change so that you can actually, you know, if you have, in this case, I basically added an out-of-control data point, and we just have to rescale so that you can see that. All right, so that does happen. You can still do preserve axis values, but that only works when you're adding data to a specific chart. Okay, so that's the add data to all control charts. The last item is a new dialog box in the non-normal capability analysis. And so I'm going to use the non-normal cycle time, which is what we use in the workbook. And in the workbook, we have an example where we do process capability, non-normal, and we do our distribution fitting. And in this case, I'm just going to quickly go through and create a report using all transformations and distributions. By the way, this is considerably faster. This takes now about 20 seconds, whereas it used to take about a minute. So, you know, a good speed improvement. So the distribution that it came back with was the log logistic. And with that, what I can then say is, all right, according to SigmaXL, you know, on the sorted order, log logistic is the best distribution. That actually has the higher p-value, ADP value. Okay. We could have chosen a Box-Cox transformation as well. Box-Cox is still a good, and a log normal is also a possibility. What I want to do is I'm going to stay with what's in the workbook, which is the log logistic. So I'm going to now do a process capability study. So I'll go back to my data, process capability, and then we'll do the capability combination report. And the cycle time, upper spec limit is 1,000, and the specified distribution. Okay, so this is what's new. If you previously, when you did specify distribution, all you had was a drop-down list. So now it's a little more visual, and so I wanted the 2-parameter log logistic. Okay, so essentially I get kind of it's a static bitmap, but at least you have a little bit of a visual as to what the distribution looks like. So it just it makes it a little bit easier, and then you click OK, and it gives you your process capability report for using the 2-parameter log logistic. There we go. Okay, so there's our log logistic distribution fit. So that actually concludes my my presentation as far as what's new. So to recap, we have compatibility with 64-bit. We've updated the cause and effect template with a Pareto chart. We've updated the failure mode and effects analysis with the sort, the RPN sort. On both gauge R&R and attribute MSA, you can stack the data to do further analysis. And we have the add data to all control charts. And then we've added the distribution fitting, just the more visual selection of your distributions.